Hello, my dear aspirants. A very warm welcome to you all. I hope all of you are doing great and preparing well for upcoming examination. So, all these days, as you've seen, I was not being able to post the videos, but I'm thankful to my other faculties who are posting daily videos for all the aspirants of Meghalaya. So, based on students' demand, I've brought a video today for you, and the topic would be time, speed, and distance. A very important topic because if you check the PYQ, if you analyze the PYQ, you can see that there were 3 to 4 questions in a single paper as well. So that is why this particular chapter holds a very good weightage for us. So if we master this particular chapter, then we can easily secure 6 to 8 marks for ourselves. Okay, so let's understand this topic without a further ado. I won't waste that much time because it's a quite lengthy chapter, so we might have to segregate this video into 2 parts, but I'll try my level best to cover as many parts in single video as possible. So firstly, very basic relation that you have to understand in this particular chapter is the relation between speed, distance and time. And to understand this relation, you have to understand this particular figure which I have given out here. Suppose there is an object and now I push this particular object. Now if I push this object, what happens is the object starts moving. So when an object starts moving, right, this particular process is known as your motion. So if you push an object and if the object starts moving because of that particular push, the object comes in motion, you would say. And as there is a motion, you get to see the parameter speed coming up. Because when a body is in motion, it would cover this particular path that you see. This particular path is known as distance. And obviously, to cover this distance, this particular object will consume some of the time. So the relation between distance and time gives you speed. So speed is simply nothing but speed is distance divided by time. You just have to remember this particular relation because based on this relation, we can solve all the questions of this particular chapter. Okay, speed is distance by time. And sometimes if the examiner asks us to get the other parameter, like suppose he asks us to get the distance, then will you modify this formula and we'll just write down speed into time. And if they ask us to get time, then we'll just write distance divided by speed. Okay, this is the very basic. Now the next part is, as we have learned this particular basic, the next thing that you have to keep in mind is the unit conversion, which is very important because examiner, what he does is, he knows that many students are utilizing the formula. So what he does is, he gives you tricky question based on the unit. So in order to convert unit to some other parameter, you just remember this thing. What? Suppose I take an example that my speed is distance by time. Okay, and suppose I say that 1 kilometer distance has been covered in 1 hour. Now I want to convert this into another unit. So suppose I want to convert into meter per hour. So how to convert in meter per hour? Just convert this kilometer into meter. And 1 kilometer there is 1000 meters. So just write 1000 meter divided by 1 hour. Now if you see, this became 1000 meter per hour. Now similarly, if I want to convert from meter per hour to meter per minute, so what you'll do is just convert this 1 hour to a minute. So 1000 meter divided by this 1 hour becomes 60 minutes. So if you see, right, I'm not memorizing the formula, but I'm just changing this particular unit based on my requirement. Okay, and in 1 hour there are 60 minutes, that's why I've written 60 minutes. Suppose I want to convert this into meter per second. So what I'll do is I'll write 1000 and I'll divide it by 60 and I'll again multiply by, in this minute there is a 60 seconds, so 60 seconds, and that way you can see that the unit has finally converted into meter per second. And if you cancel these terms, you would end up getting what? 5 and 3, which is your 5 by 18. And this is what is given in this particular formula, that in order to go from kilometer per hour to meter per second, you have to multiply the particular speed by 5 by 18, and in order to go the vice versa, meter per second to kilometer per hour, you multiply by 18 by 5. Simple. Got it? And also time conversion I have explained, so I am not going to explain again. Now yes, see how to utilize this particular concept in your previous year question of MPSC LDA. So this is the question which was asked in MPSC LDA. So before solving this question, let's solve a simple question and then we'll solve this particular question by utilizing the concept that we have just learned. So the simple question says that, suppose I ask you to get me the speed when a person has covered a distance of 500 meters, and in order to cover this particular distance, he utilized the time of 20 seconds. So we know that speed is distance by time. So distance is 500 meter and your time is 20 seconds. So if I cancel this, you'll see that we are getting 25 meters per second. So we have got 25 meter per second. Now suppose I ask you to get me the answer in kilometers per hour. In order to get this into kilometer per hour, what we'll do is we'll just multiply 25 by how much? 18 by 5. And that way if you cancel this, you're getting as 90 kilometers per hour. Right? Sometimes students get confused from when do we multiply 18 by 5, when do we multiply 5 by 18. So it's very simple. See, kilometer is a greater unit. Yeah, kilometer per hour is a greater unit. So if you want to go from greater unit to smaller unit, that is your meter per second, you always multiply by 5 by 18. And if you want to go from smaller unit to greater unit, then you multiply the opposite, that is your 18 by 5. Okay. So we have learned this particular concept here. So let's utilize this particular concept to solve this question which was asked in MPSC LDA. Right? Okay, let's see. What's given? See. A person has to cover a distance of 6 kilometers in 45 minutes. That means that person is covering 6 kilometers in 45 minutes. Okay, let's write down the condition first, whatever is given. And also, in order to solve the question of these questions, always try to draw the figure in order to understand the particular condition. So I'll draw a line. This particular line is how much? This particular distance is 6 kilometers. Okay, from this point, this is 6 kilometers. And to cover 6 kilometers, he took time of 45 minutes. This is the total time and total distance covered. But the examiner, what he did is he segregated this into two parts. See, one half they are saying. One half means half of this part. So the first part that you see out here, which would be how much? 6 half would be 3 kilometers and the remaining half would be 3 kilometers. So this first half, which is your 3 kilometers, has been covered in how much time? 2/3 of total time. So 2/3 of total time means just get the 2/3 of your total time. What is the total time? We have 45 minutes. So just get the 2/3 of this 45. And if I cancel this, you would notice that out here you're getting 30 minutes. That means at first to cover this particular part, this particular person consumed 30 minutes. So how much time we are left? We are left with 15 minutes, right? Because total is 45 minutes, so we are left with 15 minutes. So this particular person needs to cover 3 kilometers in 15 minutes. So what should be the speed? So now in order to get the speed, we know the formula of distance by time. Just use this and get the answer. Distance is how much? 3 kilometers. And the time is 15 minutes. Right? But if you see the option, if you see the answer, the examiner asks you is that he wants to get you the answer in kilometers per hour. So this kilometer sorted. This I want to make hour. And in order to convert from meter to hour, you always divide the minute by 60. And this way you'll get hour. Right? And as this double division below the main division, always remember that the bottom number goes at the top. So in short, what you'll get is you'll get 3 kilometers into 60 divided by 15 hours. Now see the unit has become kilometers per hour. Just cancel and get the answer. 15 fours are 60. So that means 12 kilometers per hour. This is the speed with which he has to cover the remaining distance if you want to cover the entire journey in 45 minutes, which is option number B. Easy, right? So see, we are still sticking to the basic, but we are solving a complicated question like this one, which we're asking in LPSC LDA, right? Now I want to move to the next concept. I hope this is clear. So try to solve some more questions, and to get those questions, you can download our app and download the PDF from there where I've given more questions of such type. So you can practice those questions, okay? Now I want to move to the next concept where we see a train, okay? A train passing a person and a train passing a bridge or tunnel. Let's understand this concept in a very simple language. It's quite simple when you understand with the image. Suppose there is a person standing out here, okay? And this is a train which is going to cross this particular person. And now after a while, if you notice, this person is here only, but the train has reached this point. So what you notice is, you can notice that this person, when he sees the train, he'll feel like he is crossing the length of the train, right? This is the train length. Okay, so the distance travel would be what? Distance travel would be the train length. Yes, because you're standing and the train is passing in front of you. So you'll feel like you are covering the length of the train. Okay, so always remember when a train crosses a man, okay, a person or a post or a signal or an object, then your distance that will be traveled will always be equivalent to the train length. Easy? Train length. Got it? Train length. But if I come below, which includes a bridge. So now if you see that this is a bridge. So bridge is also quite a big structure, right? So we cannot ignore the length of the bridge. We have to take the length of the bridge. Like why did we not take human length? Because we are not sleeping. If we were sleeping, then obviously I would have taken my height as well. But we are standing, right? So it's like a point to us. It's like a point, a small point, which is very much negligible to the train length because train is quite long as compared to us. That is why we are just considering the train length. But out here, if you see, the bridge is not small, right? It's quite long. So if we say that this is the bridge length, and if you see that a train is crossing this bridge, so what you'll notice is once the train crosses the bridge, you would say that the total distance crossed is what? The total distance crossed would be the train's length along with the bridge length. So always remember, when a train crosses a bridge or a tunnel, in that case, the required distance will be train length plus the structure length. That means in simple language, if I say the distance in this case would be train length and the bridge length together. Got it? That's it and nothing else. Now, as we have learned this concept, let's utilize it in the question given in your previous year paper LDA. See, this is the question. So they have given that the length of a bridge which a train 130-meter long crosses. So we have a bridge, and this bridge, who is crossing? A train. This is a train. And what is the length of the train? The length of the train is 130 meter. 130 meter long train is crossing this particular bridge. Do we know the length of the bridge? We do not know. So let's assume that the bridge length is BL. Right? Is traveling at 45 kilometers per hour. So this train is traveling at a speed of 45 kilometers per hour. Crosses in 30 seconds. So to cross this entire bridge, it takes him time how much? 30 seconds. So what is the length of the bridge they are saying? Okay, let's get the length of the bridge. Always utilize the same formula. What? Speed is distance by time. Now in this case, what is the speed? Obviously we'll take the speed of train because here the moving object is only the train. So train is moving at 45 kilometers per hour. And now if we notice that out here it is kilometer per hour, but the remaining is meter second, right? So we have to convert this into meter per second. So to convert into meter per second, we have to multiply this by 5/18. And this way this entire unit has converted into meter per second. And the distance will be what? So just now we have learned. So when a train crosses the bridge, the distance would be the train length along with the bridge length. So train length is 130 and bridge length is BL. This is the total distance and the time taken is 30 seconds. So just write 30 seconds out here. Simplify this equation, you'll get the answer. So 30, if you take it there, if you cross multiply, this 30 gets multiplied at the top. So we'll have 45 into 5/18 into of 30, and this will be equivalent to 130 plus the bridge length. So if you cancel this term, 9 2s are 18, 9 5s are 45, 2 15s are 30. So if you multiply this, 15 5s are 75, 75 5s would be 275, and here we have 130 plus of the bridge length. So therefore, the bridge length would be how much? You would say 275 minus of 130, which is equivalent to which is equivalent to, so this is 375, 245 kilometers or meter. This is your right answer, option number C. Got it? So do you see how we are utilizing the concept that we are learning? Right? Now let's see another question. And see, if some of you are finding it quite fast, then you can lower the speed and see it carefully. Okay. Now see, this is another question. Exact same concept, but now the examiner is very cunning. What he did? He changed the unit. Right? He is giving miles per hour. So let's do it. A train traveling at a speed of 75 miles per hour. So we have train speed given to us, which is just 75 miles per hour. Enters a tunnel 3.5 miles long. Okay, so the tunnel length of the tunnel, I'm writing LT, is 3.5 miles, and the train is 1/4 mile long. 1/4 mile long means if you divide 1 by 4, how much you'll get? If you give decimal, you get a 0. 4 2s is 8. Subtract, you're getting 2. As we have decimal, we have a 0. 4 5s are 20, and in that way we are getting 0.25. That means the length of the train length, I'm writing LT, is 0.25 miles. Okay, this is the condition given. How long does it take for the train to pass through the tunnel from the moment the front enters to the moment the rear emerges? That means we want to find the time. We want to get the time. So which formula will use? Speed is distance by time. Simple. Always this is the main formula. How much speed are we going with? We are going with 75 miles per hour speed. How much distance will cover? So we have length of the tunnel and length of the train. So we have to add them up. Yes, I told you before. So just add them up. 3.5 plus 0.25, and we'll divide it by time, and time is what we want to find. And when I add them, how much you're getting? You're getting here 3.75. So I'll take this time there and I'll bring this 75 miles per hour out here. So time is here, and here this will be divided by 75 miles per hour. Per hour means this one. So if I remove this, I can write into hour out here. It's the same thing. And here we have mile. Now if you notice, your mile gets cancelled out. So whatever answer will come in hours. Okay. So remove the decimal. When I remove this decimal, you'll get 100 at the bottom. Yes, now cancel the term. So 25, 3 is 75. 25, 15 is 375. 3, 5 is 15. So we are getting 5 divided by 100. Now this is hour, but see the option, they are given in minutes. So we have to convert hour to minutes. So how to convert hour to minutes? Just multiply by 60. Right? And this will be the answer. So if you see, 5 into 60 would be 30, divided by 10 would be how much? 3 minutes, which is option number B, which is my option number B. I hope you got it. Yes. Okay, let's see some more question. Okay, But now the other question that we have to cover would be on the basis of relative speed concept. So what I'll do is the video might get too long. So we'll cover this particular concept in the next part. So this was the part one. The next part would be part two, where we'll cover this particular concept of relative speed when we move in same direction, when we move in opposite direction. And I'll tell you that as we are doing with the very basic method, this particular concept would also seem very, very easy to you. Okay. So stay tuned. I'll upload the next video maybe tomorrow or today evening itself, so that you can have a watch and practice as much as you can. But even if you want, you can also join our paid batch, which is available with you, the MCQ batch, where we are practicing MCQs daily. Okay. So we are focusing on 22nd August exam. So till now, 8 class has been passed. So this 8 class recorded sessions will be available to you, so that you can watch the recorded and come to the live class which we are conducting. So you can join this batch. You can contact this number to get the details. And also, if you don't want to join the batch, then you can at least get yourself a test prime, which consists of test series based on your exam. So go give the test series and make your selection closer. So I'll see you in the next session. I hope you like this session. If you like the session, make sure to comment down below next session, so that I'll get the motivation to bring second part of this particular chapter. So keep practicing and all the very best. Thank you. I'll see you in the next session where we cover the remaining part. Okay, thank you.